Take a second to just look around the room. It feels effortless. You open your eyes and the world is simply there. Intuition tells us our eyes work exactly like camera lenses, smoothly taking in the light and recording the environment. For centuries, science agreed with this common sense. This is the classical bottom-up model of perception. It assumes that light and sound exist objectively, hit our sensory organs, and the data flows in one direction to the brain where a picture is reconstructed. This assumption makes reality feel immediate, stable, and completely independent of ourselves. You are here and the world is out there. It feels undeniable. But this model ignores the logistical reality of where the brain actually sits. Look at this medical illustration. The brain is entirely sealed inside a pitch-black, silent, bony vault, completely cut off from the external world. It never touches light or hears sound. The only things breaching this vault are action potentials, noisy electrical impulses from peripheral nerves. How does an isolated organ take a stream of impoverished electrical static and render the vivid, seamless, three-dimensional reality you are experiencing right now? Neuroscience suggests a different mechanism. You aren't passively seeing the world. Your brain is actively generating it. You are experiencing a controlled hallucination. To understand how this works, we have to look at a framework called predictive processing. The core idea is simple. The brain does not wait for sensory information to arrive. It predicts it. The brain constantly runs a generative model. It uses your lifetime of past experiences to construct a top-down hypothesis of what is most likely happening outside your skull. It is constantly projecting this guess downwards toward your eyes and ears. Instead of transmitting a high-definition video stream, the eyes act as error reporters. They only signal the prediction errors, the discrepancies between what the brain guessed and what the raw environment looks like. The seeds of this idea were actually planted in the 19th century, when the polymath Hermann von Helmholtz argued that perception relies on unconscious inference. Today, the math backs him up. Perception is statistically identical to guessing. Our lived reality is simply the brain's most probable hypothesis, continuously corrected by the senses. We can observe this generative model in action through visual illusions. If you look at these shapes, your brain immediately perceives a bright white triangle sitting right in the center. There are no lines connecting those corners, but prior experience dictates that objects overlap in nature. The brain forces a shape into existence, inventing the missing edges. The most revealing part is that knowing the triangle is fake doesn't dissolve the illusion. The predictive model operates entirely beneath your conscious awareness. It doesn't consult your logical beliefs, it consults its own math. 20th century visual neuroscience mapped this exact hierarchy. Researchers discovered that higher cortical areas aren't just processing refined pixels, they are encoding complex, abstract assumptions about the physical world. When there is a conflict between incomplete raw sensory data and a deeply entrenched internal prediction, the brain will almost always hallucinate the prediction. If waking perception is a controlled hallucination, dreaming is an uncontrolled hallucination. During REM sleep, the brain turns off bottom-up constraints from your sensory organs. The generative model runs at full power, creating a vivid, compelling reality with zero external pushback. To maintain a grip on reality while we are awake, the brain relies on precision weighting. It constantly calculates whether to trust its own internal model or to trust the external prediction error coming from the eyes and ears. When this delicate weighting system breaks down, we see the onset of clinical conditions like schizophrenia. The brain assigns excessive weight to its internally generated signals. The resulting hallucinations overpower reality because the brain is unable to learn from contradicting sensory input. Similarly, chronic anxiety acts as a rigid, highly entrenched predictive model. The brain constantly expects a threat, forcing the nervous system into anticipatory stress, regardless of how safe the actual environment is. Everyday waking life, our vivid dreams, and clinical psychosis all rely on the exact same biological machinery. They only differ in how tightly the brain's internal hypothesis is tethered to the outside world. Evolution favored a brain that hallucinates reality because of latency. Waiting for perfect sensory data to identify a sudden threat guarantees you'll be eaten. Processing perfect objective truth takes too much time. Your brain evolved to keep you alive, so it operates slightly in the future, rendering a highly compressed, actionable simulation before the raw data has fully arrived. This generative model also looks inward, predicting your heart rate, breathing, and blood chemistry. By bundling these internal signals with external predictions into a single, cohesive narrative, the brain creates the experience of a self, a persistent entity that owns the experience. This self is effectively a transparent simulation. It is transparent because the brain's modeling process is so efficient that the model itself remains invisible to us. We don't see the simulation, we just see through it, mistaking the brain's most useful story for a permanent, objective reality. Long before brain scanners existed, ancient philosophers suspected we were only observing the shadows of reality, cut off from the true nature of the universe. Today's neuroscience offers a practical way to understand this. Your everyday existence is a continuous, collaborative negotiation. The brain makes an educated guess, and the environment pushes back. Everything you see, feel, and love represents your brain's most successful, survival-driven story about the dark void outside your skull.